Okay, so it's time to talk about the groups on the periodic table. And the first thing we want to recognize is that not every column on the periodic table is considered a group. The columns on the periodic table that are groups 1, 2, 13, 14, 15, 16, 17, and 18. We're going to start with group 1, the alkali metals. Now, the alkali metals are in the first column, but not including hydrogen. The alkali metals are also what we call a family. Not all groups are considered families. We'll find out throughout this lesson there are only 4 families on the periodic table. The alkali metals is one of those families. The families stand apart from the rest of the groups because all the elements in a family behave very similarly. All the elements in the rest of the groups may behave in a similar fashion in terms of how they bond, but not to the same extent. So when we look at the alkali metals, one of the biggest things you'll notice, we did the valence electron configuration for these guys earlier, and you noticed, again, with the exception of hydrogen, they all have one valence electron. That means they're all going to bond very similarly. They all want to lose that valence electron, and they do so very readily. They're extremely reactive. They're the most active or reactive metals on the planet, and they're never found uncombined in nature. Uh, you'll see we have francium and cesium as the most reactive. Francium is probably the most reactive, but we just can't isolate much of it, so it's hard to actually prove it. So cesium usually gets the nod. If you click on the link here, you'll see a video on the reactivity and even some of the physical properties of these metals, the group 1 metals, and how soft they are. As you move down the table, lithium, sodium, potassium you could cut with a plastic knife. It's pretty interesting, so feel free to have at that one. The group 2, or alkaline earth metals, are these guys right here, right next to the alkali metals. They are the second most active group or family of metals on the periodic table, and they're also never found uncombined or alone in nature. They're fairly reactive, but not to the same degree. You'll find if you click on that video, one of my favorite lines in it is the gentleman says that as you move down the group, you'll find the reactions become slightly more terrifying, which is the case. As you'll see with cesium, it's pretty terrifying. None of the reactions with the group 2 metals are terrifying, but some of the guys in here, if you put them magnesium in warm water, you'll see it bubble. Calcium can be in cold water, and you'll see it bubble. The guys in group 1 do more than just bubble. And then we have groups 3 through 12. This block of elements called the transition metals. The transition metals are where you find your more common metals, the ones you guys are familiar with. Copper, silver you'll find, gold you'll find. These are all transition metals. Zinc, chromium, iron, these are all found in this group here, also referred to as the D block. When we did SPDF, in terms of our energy levels. Okay, the transition metals are the ones that start to fill the D block, and it's why they behave so unpredictably. Right, this is one of the big things you'll see. They are unpredictable, and I've referred to them time and time again as like the adolescents of the periodic table, the teenagers. You don't ever really know how they're going to behave. They're influenced very easily by their peers, just like teenagers. So they're unpredictable, but it's all based on how they behave is based on what they're with. So another important thing to remember about the transition metals, they form colored ions when you dissolve them in solution. So if I have copper chloride, the salt and I put that in solution, it'll become a bright blue color. That shows up on the Regents exam every single year. They're the least reactive group of metals, which is a good thing. All right. If they were really active, copper wouldn't be good for making pots and pans out of. You don't want what you're cooking in to be reacting with what you're cooking. So silver, copper, iron. Iron is the main component in steel, stainless steel. The fact that they're inactive metals is actually a very, very good thing. And then at the very bottom, we have uh, the miscellaneous group, the BCNO group. And it's sort of a hodgepodge, like the shepherd's pie of the periodic table. Each group in here, while they are groups, 13 through 16, the elements in these groups don't necessarily behave similar to one another. For instance, oxygen at the top of group 16 is a gas at room temperature. Polonium is a radioactive metal. That's at the bottom of group 16. Not exactly similar, but they can form a similar number of bonds. And the last part about the BCNO group that we'll find, there's something in it, a staircase. Probably should have picked a color other than blue. This staircase separates the metals, which are underneath and to the left, from the nonmetals. And along the staircase, we have elements that are called the metalloids. And we will talk about them more in the upcoming pages. Then the last part, the last two families, two groups, which are families on the periodic table, are the halogens, which are group 17, this column here, and they have 7 valence electrons, so they have a tendency to gain 1 and become negatively charged ions, also take on a negative charge within a compound. The whole idea that 8 is great. The octet rule, they're the most reactive of all the nonmetals, which means these guys are also never found uncombined. If they're not with something else, they're with themselves. F2, O2, Cl2, Br2, and I2. And you'll find all 3 states of matter in this group, from solids to liquids to gases. Bromine is one of the only 2 liquids at STP. The last one is the noble gases. This is group 18. They're inert or unreactive. That's because they already have 8 valence electrons. So they've filled their octet, that valence shell. These guys do exist alone in nature because they don't want to combine with anything. They don't need to form any bonds. They already have an octet. Helium is the exception to the octet rule because it only needs 2 valence electrons. It's a duet, not an octet. Other than that, from neon, argon, krypton, all of them down, they have 8 valence electrons. We say 8 is great. That sort of electric stability is why they don't bond with other elements. And then the last one, hydrogen, we saw before that hydrogen was at the top of group 1, but we X'd it out. We said it's not part of the alkali metals. It's not a metal. It's a gas. So despite the fact that hydrogen is part of group 1, it's not a group 1 metal or an alkali metal. It's both a nonmetal and a gas, and it's another one of the 7-up, which we'll find later, the elements that exist as diatoms.